Hello, welcome to Tech Talk with Steve, episode 42, first episode of 2023. Today we're going to be talking about empowering sustainable space. So what is that? What are we going to be talking about? You may have heard terms floating around out there like digital electricity and fault managed power. You may, if you're following the latest NEC codes, have noticed that Class 4 power is now in there. This is the kind of stuff that we're going to be talking about in this session. And today we have a special guest. Luis Suau is the Chief Business Officer at Sinclair Digital. He's also an independent digital building consultant in his own practice, Luis Suau Consulting, LLC. Luis is a 26-year veteran of Cisco. He's previously worked as the technical leader in Cisco's IoT business unit and a key member in developing their digital ceiling and digital building solutions. After the completion and opening of the highly innovative Marriott Sinclair Hotel, which we're going to talk about, it's a really cool place, and Luis has got some good stuff to share with us. After the completion of that, he left Cisco to pursue his passion of expanding the scope of digital building systems with the goal of developing a building as a DC microgrid. Additionally, Luis and I are both going to be part of a group of 6 co-presenters in a pre-conference masterclass on designing for PoE lighting and automation at the upcoming BIXI Winter Conference in Tampa. We'll also be side by side at the show, and Luis is going to have some cool stuff to show us while we're there. Welcome, Luis.
Thank you, Steve. It's a pleasure to be here, and happy 2023.
Same to you. It's always good to see you. You and I have teamed up together previously on a couple of different presentations around the globe. So it's always good to get together with you. So I kind of teed it up in the beginning, digital electricity, fault managed power. I've seen those terms used interchangeably. And this is what you do, right? This is the business that you're in.
It is. Basically, what separates Sinclair Digital from other people in this space is that we are focused on creating a building as a DC microgrid. So our ultimate goal is the elimination of all the traditional class 1 power within a building and encompassing it in a digital form, DC form in particular. And that's because as buildings start to deploy solar, and when you really look at it, it's DC power in, and you have to go through a double conversion process because in order to take that solar power and make it usable, you have to invert it to AC to move it with traditional building infrastructure. And then pretty much every device in a building today is already DC on the inside because of the electronic components parts of it. So that gets converted back to DC. And so that is a waste. It's a 2 times the waste actually from a solar perspective.
Very inefficient.
Even if it very inefficient, even if you're not thinking of solar, just from a traditional grid connected perspective, you end up using very, very low if energy efficient. They're not very energy efficient transformers. So I think about the devices in a building. Usually, when you plug it into the wall, there's a transformer of some sort. That transformer becomes warm from the conversion of energy, and so they're not very well in terms of effectiveness. So even by doing that and moving it to whether it's PoE, digital electricity, or USB-C, because those are the 3 DC fault managed technologies that we have to play with. You're actually going to save by moving all those heat loads, centralizing them at the electrical room of the building, and being able to distribute those throughout the building. So there's efficiencies just from that perspective. And then if there is solar in the midst, then it's even more effective.
And you mentioned PoE there, and I think most of us may turn my phone off since I didn't do that ahead of time. Most of us are familiar with PoE and the fact that with those class 2 circuits like PoE, we're limited to 100 watts, and typically you're only getting 75 to 90 because of the voltage drop over the wire. With fault managed power, we're talking a
That's
lot
correct.
more power,
And
right?
yeah, well, fault managed power is more bulk power, so you're not limited to the 100 watts. You're really looking at the fault, and so it's engineered so it's your fault managed power is under 450 volts, and you're managing the power, so you're not restricted to the wattage calculation that exists for class 2 power today. So yeah, we power remote switches, a couple of thousand watts that we send power using fault managed power. And what that allows us to do is that it allows us to bring the switch closer to the endpoints. So you don't have to worry about massive cable bulks. In a traditional MDF, IDF kind of situation, you end up with cable trays and massive cable pools. And so by putting the switches closer to your end devices, now you have shorter cables to deal with. But then you can use fault managed power to get the power out to that switch.
Right. And I would imagine in those cases, you're probably using fiber for the data portion of it.
That's correct. So we use a hybrid cable that gives us the uplink connection from the remote switch back to the IDF, as well as the power capability to power that remote switch. So that's
Gotcha.
our standard design philosophy. Obviously, some customers may not want that, and so we do centralized designs as well, but we recognize that they're not as efficient.
And I imagine there's a much lower heat profile to the fault managed power cables than if you had bundles of PoE cables in trays running. I imagine it's not quite the issue that you have
That's
where
correct.
you're running 90-watt PoE. You're going to get a fair amount of heat coming from that.
That's correct. And the beauty of it is in the pulsing of the power. So that pulsing does reduce the heat load that is generated on the cable, the resistance and everything else. It just makes it easier to deal with.
Right. So it sounds like Edison was right.
Edison was right.
Yeah, DC seems to be the way to
Absolutely.
go. And
That is correct.
we're not talking small buildings here by any means, right? We're talking pretty decent sized facilities that you could power. And I think you guys use a product called Volt Server, correct?
That's correct. So we use volt servers, digital electricity transmitters, and receivers. If you really kind of start digging into the whole fault managed power, uh, phenomena, they kind of started. They were the first company that had a product. Of course, we would deploy it as a limited power source. And so there wasn't a specific call out for the technology, which there is now with the 2023 National Electric Code. Still, Class 4 power can coexist in the same pathways as PoE, obviously not bundled with PoE, but it could ride the same cable trays, obviously with separation, and it is doesn't have to go in conduit, and it has the same kind of safety um, expectations that we expect to see with PoE, where you will not die if you come in contact with it, and that's the whole point of it. So when the IEC has kind of looked and developed this shock curve over the years, along with organizations like UL, and the whole point of the fault managed power is to manage that fault so that you don't die in the process should
Gotcha.
you come in contact with it.
And we're talking, hundreds of volts, thousands of watts, and it's still safe. If you touch it, you're not going to get electrocuted.
That's correct. With the digital electricity portion of it, it kind of feels like static shock that you would get, wintertime, fresh carpet, in that kind of environment. That's kind of what it feels like. But yes, it does immediately turn off, and you're not electrocuted.
Good safety feature to have. It's interesting to see the progress of this, and I kind of I hinted at this at the beginning, and I know there's other buildings too, but the one that I've been to is that Marriott Sinclair Hotel in Fort Worth, and I remember doing the tour in the building as you guys took us through, and looking at all of the things in the building that were not being powered by traditional power. Even the hotel rooms, they had convenience 120-volt outlets, but it wasn't the whole room powered that way. Everything else in the room was powered via PoE locally, fed by the digital electricity coming from down at the main floor or the subfloor of the building, correct?
That's correct. So that building is was built in 1929. It's 103,000 square feet. It currently has 300 tons of VRF air conditioning, and the power bill is in the about $7,000 a month range, and that's for 165 rooms. It's 17 stories tall. It's got a restaurant with a separate bar and laundry and all of that. And when you look at the power consumption of a structure like that, knowing that the windows, they're historic windows, so they're not the best in terms of energy ratings, or the thermal envelope of the building is really not, because it was built in 1929. So when you think about it, that the energy consumption of that building is spectacular, and that's because we've removed off of the regular power system things such as the lighting, the mini bar. There's a television embedded in the bathroom vanity. All that power is just now on a PoE network, and when power comes in into the building, it's immediately converted from AC to DC, and then it's moved out via fault managed power. The switches are actually inside each hotel room and throughout the facility. Um, so the DC conversion immediately happens, early on in the building, and so all that heat is kind of pushed out. The heat from all the different transformers is centralized where the electrical equipment is, and that's where you find the volt server digital electricity rack that then sends power out to all of the rooms. In the process, we removed a bunch of conduit, a bunch of electrical work. Um, there was approximately a 25% savings in electrical work uh, that resulted from a conversion over to digital electricity and PoE throughout the building.
Wow. Wow. Now here's a kind of a sidebar question to that. Thinking about, the conduit coming out, all your traditional electrical cabling isn't needed anymore. Who installs this? Is it installed? Does it have to be, as a class 4 circuit? Does it get installed by an electrician, or can it be installed by a low voltage contractor?
Yes. Although the different states have not adopted the energy code yet, obviously that's the first part of what needs to happen going forward. But class 4 can be installed by low voltage electricians, and
Wow.
so or a low voltage shop. So there is no conduit requirement, and so it gives an advantage, because now you're looking at a lower cost labor to install that aspect of the technology. So yeah, the cabling can be installed by low voltage, and the work itself, it's installed by low voltage. Now the caveat there is the input power to the volt server system still requires electrical work, and so that's where the electrical function will concentrate. The rest of it from the transmitter on out then becomes a lower voltage component. Obviously, Installing the PoE switches can be done by low voltage work as it is done today, and then PoE, downstream from the switch.
Gotcha. Gotcha. Now I remember too that most of the lighting in the building was LED, if memory serves. So, in that Sinclair hotel, the majority of the lighting, I think there may have still been a few incandescents, but I think for the most part it was all LED lighting, correct?
Yes. So the thing is with PoE, you got to target LED, right? You need a DC load, and so incandescent lighting is not DC. So if you look at the Sinclair Hotel, you walk in and you see this beautiful um, kind of luxury 1930s building, and you see round, typical bulbs hanging off chandeliers, and so you think it's incandescent, but it's not. It's LED, and it's all powered over PoE. So in the Sinclair Hotel, inside the guest room, all of your headboard, any lamp, um, it is actually all powered PoE. And we have in each wardrobe, there's a lock cabinet where you will find a switch with PoE drivers that then power all of the lighting in the room. And because of that, we also have motorized shades, which are PoE. So as a result, when you walk into the room, there is a 5-inch touchscreen uh, that you can see, and that touchscreen then will have scenes, and you push different scenes. Like there's a good morning scene, and it opens up the curtains, and I think that the shades go up halfway, and it does also trigger some of the lighting, and so there's a um, relaxation scene that you press, and it's got different scenes that it acts out in the room as well.
Wow. And all
Now
those
we did another project we did another project that after the Sinclair called the Marcel Hotel in New Haven, Connecticut. There, um, because we had different types of wall switches on the fixtures themselves, there you have a higher degree of room automation. So you can actually trigger many additional scenes in the room. But the Sinclair is known for its variety of PoE. Like I said, the mini bars are PoE. The television that's behind the bathroom vanity, all that stuff is PoE powered as well. So it actually has a much greater diverse implementation of PoE than the Marcel.
so window treatments and everything else all controlled by PoE.
That's correct,
Wow. Wow.
and that's we're seeing that happen more and more. The Sinclair Hotel kind of opened. That was the first implementation of motorized PoE shades. That was with a vendor, Somfy, and we're seeing that same scenario with a combination of lighting and shading powered by PoE both in offices and hospitality uh, customers. So I know that there's a number of lighting installations, office lighting installations that have taken place in New York, but also with motorized shading.
Wow. Now, hotels and a lot of commercial buildings will have backup power generating systems like a diesel generator, and the Sinclair is no exception. But you guys replaced the diesel generator with a power bank, and if memory serves, it could even power the elevators in the building.
That's correct. It does. So the Sinclair Hotel is a high rise, and with the standard building codes, a means of emergency, life safety powering is required. Typically, that becomes a generator. At the Sinclair, the generator was replaced with a lithium ion energy storage system, and the goal of that was the location of the generator in the Sinclair would have been or is in the basement, alongside of where the restaurant is, and to avoid the potential of noise disruption, potentially fumes, and avoid having to exhaust the diesel exhaust all the way up to the 17th floor. Um, we partnered with LG, and we basically brought in from Korea the first large scale building energy storage system that was certified for a UL 924. And that's what's installed at the Sinclair. And it gives you about 6.5 hours of emergency backup storage. And it does run all lighting and the elevators. Um, that's what is there.
Wow. Now, I imagine that testing has to become part of everything you do, as it does with all of our installations. And you've used our test equipment. I think actually you had some testing going on up in Connecticut with the Marcel Hotel, right? Where you guys were able to use one of the testers to troubleshoot part of your system.
Absolutely. So officially, we only use the AEM testers. Um, they have saved us from numerous situations in the past, and so we're very appreciative. Obviously, the cable plant is ultimately what's required for a successful implementation. If you don't have a good cable plant, then you don't have the connectivity that you need. Um, for the type of network implement solution that we deploy today, you need to have very resilient connectivity. Um, Actually, things start to break down if you're not doing like sub 10 millisecond response times. So it's critical that you have a good cable plant. And we had situations where electrical or cabling is bid out, and then the bidder then subs it out again, and we ended up in a situation where there were cable splices, cable was not properly terminated, and without the use of a tester like the one that you make, we would not be able to solve these problems, identify them, and get them corrected um, for our project. So it is very crucial that you have uh, cable tested and validated um, and certified, before you bring up your endpoints.
Right, right. And then of course then comes the troubleshooting, looking at the PoE, having the ability to do a PoE load test, those kind of things all kind of, falls in there because I mean, everybody always points at the cabling, right? It's got to be the cabling,
Absolutely.
but sometimes it could be a piece of equipment, and the ability to be able to, narrow that down through a process of elimination can be very helpful in a situation like that.
Absolutely. And that's where you need a known device that functions, right? And that's the whole purpose of the tester. That not only can it give you information about the cable plant itself, but it's a trusted device. It's known to work, and so there's no question of, is it a bad driver? Is it a bad switch port? Is it the patch panel? All of a sudden, now you have a platform with which you can test it and validate it.
Right, right. Makes sense. And that's kind of why we designed, both the Test Pro and the NSA around that whole intelligent building, smart building, digital building scenario, because that is the future. That's where we're going. It's not just put in the data cabling and be done with it anymore. Everything's going digital. We're ever conscious, regardless of which side of the climate equation you sit, we all need to be conscious of how we treat our home, our planet. This is where we live, guys. We got to take care of it, right? So all this intelligent buildings, digital building technology is really driving at that sustainability that we talked about. Keeping our emissions low, all those things. It's all good. It's not a political thing. We just need to take care of our environment. Um, we did have one question come up while you and I were talking about who installs it, electricians versus low voltage, from Eddie Brady, one of our partners over in the UK. What effect will this have on the traditional electrical trade? Surely they'll fight DC based systems. And I know from my experience over the last 30 plus years, anytime a low voltage guy wants to try and do something the electrician feels like they should be doing, it creates this fight. Um, do you anticipate similar issues like that going on?
Well, I don't really think so. I think that the electrical world the electricians world will kind of step up and learn IT technologies. They'll have to. It's coming. IT technology is in every aspect of life today. Look at the car, right? If you were simply a transmission mechanic in today's automotive world, you kind of see a limited future. So you have to up your skills and learn a little bit more to deal with electrification. And I think the same thing is happening. Um, I think a lot of it is also the approach that's taken. Um, you shouldn't try to isolate people and kind of keep them apart. You want to bring them together. So I see in the U.S., I see Bixby and Nika starting to come together. The reality is that a DC and or IT approach is going to make work more plug and play, quicker to install, which actually means that your costs could go down if you're the electrical contractor. Now, do you fight a battle with a low voltage contractor to kind of win the business? I think that they both have to come together, and you'll see electrical and low voltage low voltage partnering more, at least from what I've seen, where I've been exposed, that the two will actually cooperate and work together and win jobs, um, and then be able to deliver them faster using a digital technology, digital approach. And at the end, the customer's happier because they're going to get a more resilient building. They're going to get more building intelligence that then can optimize and make their building more valuable.
That actually makes a lot of sense, because I remember, back in the 90s, I started to see electrical contractors who were embracing the low voltage cabling, and they were learning it. And not all of them would adopt it, but there were a lot that would. So this is kind of just another step in progress for them, I think. And I think it'll,
That's
like
correct.
you said, they're going to be encouraged to work together. When you've got the trade organizations like Bixby and Nika, who are going to encourage them to play nice, I guess is a way to put it. It's in the interest of progress, right?
They need each other. That's what
Yeah,
it boils down to, is that they need each other.
exactly. Well, this has been fantastic, Louis. I really appreciate you joining us today. We're at the almost at the bottom of the hour. Anything else you'd like to add before we let everybody go here?
Actually, I would. I urge you to go and Google a Department of Energy document titled DC Lighting and Building Microgrids. It's authored by Gabe Arnold, and he's with PNNL, or Pacific Northwest National Labs. And it tells you about the efficiencies to be had with building DC microgrids, or the approach of building DC. And it only talks about lighting, but it really is applicable to all other aspects of a building. So read it. It's only 5 or 6 pages long. It's game changing as we move forward.
Excellent, excellent. So yeah, I just typed that into my Google now, so I'm gonna go read that. That'll be very interesting. As I mentioned, we're gonna be at Bixie. We're gonna be side by side at Bixie. So if you're interested in seeing the digital electricity, come on by booth 820. We'll be there at the show, and as I mentioned, Lewis and I are both going to be co-presenters in a master class ahead of the conference as well. So we appreciate everybody's time, and thanks again, Lewis. This was great.
You're welcome, and I'll see you at Bixie.
Thanks.